Good afternoon, everyone. Last class we have started with fourth normal form, but we were not able to discuss because of my net issue. So, hopefully today it will be solved. So today it's actually solved. I don't know, like probably net will be there. So what happens is that when we studied the for like till BCNF, we have studied first normal form, we studied second normal form, third normal form, which was given by Dr. E.F. Code. Okay, so later the third normal form was modified. Okay, the third normal form was modified and into a more restrictive model. So you can either call it 3.5 normal form, or you can say it's Boyce normal form, Boyce code normal form. So as you can, from the name, it is very clear that it is given by a person, Boyce. So since he has modified the like third normal form given by Mr. Code, so that is why it is that Boyce code normal form. So today we are going to study about the fourth normal form, which is not given by Mr. Dr. Code. Okay. So but whenever there is a question on whenever there is a question on find the highest normal form, we generally start checking from the BCNF only. Okay, we don't go for the fourth, fifth, or sixth normal form. Okay, so let me share the slides. So what is as we are aware that in second normal form we had the partial dependency. In third normal form we have this one transitive dependencies. So here in fourth normal form there will be multi-value dependencies. So what are multi-value dependencies? Basically are a generalization of the functional dependencies only. So when an attribute determines a single valued attribute, the dependency is called functional dependency. But when an attribute determines multi-valued attributes, the dependency is called multi-valued dependency. So here that is there won't be any functional dependency, but there will be multi-valued dependency, since it will like determine multiple values. So it is very rare to find multi-value dependencies. Like even generally after BCNF, there hardly remains like uh, multi-value dependencies, but if you are getting, you are using, we have to find the fourth normal form. So this multi-value dependencies is represented using this double arrow symbol. So if you see this kind of symbol, this means it represents the multi-value dependency. So you have functional dependencies. We know we write in this manner, that is employee ID determines employee name, right? Or we can also say that employee ID is determined by employee ID, right? Similarly, if we go for the multi-value dependency check, there was a single arrow, there is a double arrow. So here we say that the employee name multi-determined the degree, since it is a multi-determined symbol. Okay, so we know that the degree of when we were discussing the ER diagram, so we were discussing, so we have discussed that degree is something, it's multi-valued, because for me degree may be my graduation, then my post graduation, 10th and 12th marks. For you it may be different, for you it may be 10th marks and 12th percentage. So it is degree of a person varies, right? For some person it may be non-applicable also. So such kind of dependency, if you see this two arrow symbol, that means it is representing multi-value dependency. So see, after third normal form and BCNF, if attributes in the relation have a multi-valued dependency, then it is further normalized using the fourth normal form or the fifth normal form. So in the table you can see there is multi-valued dependency. So here you can see employee multi-determines degree and employee multi-determines sibling. So here you can see Smith degree is BSc, again he is going for MSc also. So he has only one sibling, so X only is the sibling. Again Smith is going for BSc, again this is a sibling, MSc, and here, so you can see there are multiple degrees are here and multiple siblings. Okay, till this point any confusion? Till this point, any confusion? In this table, if you have any confusion? Smith is having, see, if you have multi-valued, how do you store the multi-valued in a first normal form? If you remember, we need to represent it separately. So you may ask me, ma'am, we have this BSc, MSc, we can be stored together. It is not possible. In first normal form only, it will be divided into this way, right? For this purpose, for BSc also, for sibling, we have to write X. For MSc also, we have to make it X. For BSc, why? Because there are two siblings are there and 2 degrees are there. So we have to like distribute it, right? We have to break it. It means it should contain under the unique value. For if you see for Joan, you can see here there are 2 siblings, but only 1 degree, BSc, BSc. So you can see here A and B. So if you have any confusion in the table, please ask me. Any confusion?
No, ma'am.
Okay.
No, ma'am.
So if you have such kind of table, so instead of writing these things to like, though it is in third normal form, it is in third normal form. This table is in third normal form. No, like no partial dependencies there, no transitive dependencies there. All it's in Boyce code normal form is also there. It is in BCNS also. So still there is some dependencies. It's known as the multi-value dependencies. Right? Why do we need to write it like all two times, right? Everything two times. So we go for the multi-value dependency. If there is multi-value dependencies there, so how do we solve it? We can break this table. So we can remove the anomalies by putting multi-value dependencies into table of their own. So instead, so we can have an employee degree table where the employee and the degree will be stored, name of the degree will be stored, and we can have another table, employee sibling, where employee and the sibling can be stored. All right. So instead of writing and including like this degree everywhere writing it, so we can have 2 separate tables. So this is how you convert into a normal form. So you are breaking down, you are simplifying it. Okay, so in normalization, what we do, we break down the table. So this was your entire table, employee degree sibling. So you are breaking the table into employee degree and employee sibling. Is it okay?
No.
See, again I'm saying something. So you can ask me, you know why it is like 2 times written? Why Smith is 2 times written in this employee degree table? Can anyone tell me? Can anyone tell me?
And because there are 2 degrees.
Yes, we have 2 degrees, and we know that this table was in BCNF. That means it is obviously, so no atomic value. So for what was first normal form, that there should be unique attributes, right? Single attributes should be there. So that is why we are writing 2 times. It's not that we will write Smith here and BSc, MSc. That is not possible here. Domain dependency is not should not be there, right? In first normal form. So in this way, you can change it. Now under fourth normal form, a record type should not contain 2 or more independent multivalued facts about an entity. Okay, so under this fourth normal form, a record type, that is, this should not contain 2 or more independent multivalued facts about an entity. In addition, the record must satisfy the third normal form. Obviously, if it is in fourth normal form, the table must be in third normal form. And always remember, like the table must be in third normal form, and the record type should not contain 2 or more independent multi-value data. So where you have the table employee, where you have employee skill and language. Now skill of an employee can be various, like different skills may be there, and you like in employees also can speak multiple languages, right? So according to fourth normal form, they cannot be put in together in a same one. So since record type should not contain 2 or more independent multivalued facts about an entity. Okay, we'll give you an example. So what happens is that we have to break the table. So when you have such kind of things, because skills can be multiple, similarly you can speak multiple languages. So you can speak Hindi, you can speak English, you can speak Assamese. So obviously 3 languages will be there, right? So it is not possible in fourth normal form. Even in skill also, if you have if you put all the, if you a single employee contains multiple skill, he have computer skill, he have singing skill, he have dancing skill, so that is not possible. Multiple skills together is not possible. So in fourth normal form, what we do, we break the table. We can break it as employee skill one table, and we'll break employee language other table. So you can check, we have here two many to many relationships. So as you remember from the diagram, there was types of relationships, right? We constraints were there: one is to many, many is to one, many to many. We represent it using m is to n, right? So there are many is to many relationships. So in that case, suppose an employee can have many skills, and many skills can be and also employee can speak many languages. So that is many to many, right? And similarly, that many skills can be possessed by many employees. Same skills may be possessed by all the employees, right? So under fourth normal form, these two relationships should not be represented in a single record. So it is not possible that under fourth normal form that all these things you represent under a single record. For this purpose, we have to divide the two tables. So we can represent it into two records, tables, that is employee skill and employee language. But you can permit other fields if they are not multivalued facts that are permitted in the record. Okay. So if you have any confusion here, actually compared to the other cases whichever we study, it's very easy. The fourth normal form is like very easy compared to the third, second, and BCNF. So if you have no issue, so we have this multi-value dependencies. So here in fourth normal form we have multi-value dependencies that lead to fourth normal form. So this was all about the fourth normal form. No confusion?
No, ma'am. No, ma'am.
Sure. Okay, I won't discuss like anything more on the fifth normal form, because before starting with the fifth normal form, I have to teach you about the decomposition. Okay, so when we go for like decomposition is something when we go for decomposition, that is breaking of the tables. So that happens is that we get some data loss also. Either it will be lossy decomposition or it will be lossless decomposition. Okay, so that for that purpose we have to understand the thing. So I'm not going for the joint dependency. Sorry, we are not going for the fifth normal form today. So in the next class, that is tomorrow, we'll discuss about the decomposition, and then we can go for it. Okay, just wait for some time. I have some questions for you people. Just wait. Yeah. Okay, so I'll give you some questions to do like, so you need to solve and show me, okay? So just write the question I'm writing in the PPT. Okay, just wait. Let me take a blank PPT. Let me share it. So it is on the finding the highest normal form only. Just a bit question, big long question because it's from GATE only. So we have. I'm writing the question. You just copied it down. Okay. So we have a relation R where we have the attributes A, comma B, comma C, comma D, comma E, comma H. Okay. So A, B, C, D, E, H. We have this attributes. Now we have the functional dependencies. We have the functional dependencies as A determines B, BC determines D, E determines C, and D determines A. So what you need to do, so yeah, all of you are aware only, you have to find the highest normal form. Okay. Let me write the question here. Find the highest normal form. Okay. So for now, you have to find the highest normal form. I know you have to, we have to follow some steps. Okay. So for now, I'll be showing you how to, we'll be discussing, but because for that purpose, like candidate keys should be same. So you will be answering me now what will be the candidate keys, prime attributes and non-prime attributes, and other things we will do at like as assignment. Okay. That is which, if the table will be in which form. Okay. So first the step is to find the candidate keys, right? So please help me out.
Ma'am, for that, we have to check which attribute is not in the right side. So H is not in the right side.
Yes.
So with H, we'll go for AH.
Or we'll go for AH. Okay. First, you find out what are the attributes that cannot be determined on the right hand side. Yes, H is not appearing anywhere. So obviously H will be one of the, H will be there in the candidate key. Yes, you are correct. Okay. So if we, because candidate key is something which we take always the minimum amount. So if we find closure of this one, H, so according to reflexive property, it will be finding H only. So this will won't be a candidate key. So other things, what is not appearing on the right side?
E.
Yes, E is also not appearing. So that means E will be also be there. So whatever you add, E will be also, EH will be there, right, in the candidate key. Then you add something to it. Now,
Okay.
if you find this closure of this one, EH, so you will get what? This EH will obviously, it can determine itself, like E will determine itself, then H will determine H, and E can also determine C from this functional dependency, right? But you see, this is not finding all the attributes in the table. So that means it cannot be the candidate key. We need to add something more to it. Okay. So let me add, suppose A. Okay. So if I find the closure of it, what I get? So obviously this will be found, right? AEH will be there according to the if we go for the reflexive property. From A we can determine B.
B.
Yes. And from AEH, E we can determine C. Again, BC is there. BC determines D.
D.
Yes.
And D determines A.
and D determines A, but A is already
A
present.
is already
Yeah,
there.
already.
So that means it is finding all the attributes, right? So can we say that AEH can be one of the candidate key?
Yes, ma'am.
Yes.
Okay, now what step? Now there can be more, we have to check whether there are other candidate keys or not. So what we do is that we have to find whether this A is present in the right hand side or not of any functional dependencies. So that is a shortcut I'm doing, right? So if you see A is present here, so we can replace it with D. So obviously the EH will be there. Okay, EH will be there. So if I write, so DEH will be finding itself only. So from D we can find A, from E we can find C. Okay.
From A we can find B.
Yeah, from A we can find B. So that means DEH can also be one of the candidate key.
Yes.
So in this way you are about to find the candidate key. So do I need to show you more? Do I need to show you more? Okay,
No,
I
ma'am.
have. You
No,
people
ma'am.
can solve, right? Everyone.
Yes, ma'am. We'll do it.
So see, I have not like checked whether other candidate keys can be there or not. I have shown for you for only 2. Okay, so after that your next step will be, I just took this example because in this example you have this 2EH. So EH is there, like 2 attributes are there and then we can add to it, and we have not done. So people may get confused. So I'm just showing it to you. Otherwise this process remains the same. First, what you have to do is for finding the candidate key, you have to check like in the functional dependency, which attribute is not been used. So you can see H is not there. So obviously H will be there in the candidate key. Also, you have to then check in the right hand side what is not present. E is not present. That means E cannot be determined by any of the attribute. So obviously this will also be present. Okay, so then we go for the closure of checking EH. Oh, okay. We go for the checking of closure of EH plus, but we have found that EH will determine only EH and C. So that means it is not determining all the attributes. So it cannot be the candidate key. Which candidate key is something which can determine all the attributes uniquely, and always remember the candidate key needs to be minimum. Okay, needs to be minimum. So for this minimum 3 attributes is required for determining the all the attributes. So that is why this is our candidate keys, but this is not the candidate key. Any confusion? So you have to check, you have to find out all the candidate keys. Okay, everyone understood?
Yes, ma'am.
Ma'am.
Okay, so you people need okay, so you people need to check for the candidate keys also. What are the other candidate keys are there? Then you have to find the prime attributes. So prime attributes, I hope it must be clear for now that whatever attributes make up the candidate keys are the prime attributes, right? And the whatever not things are whatever the attributes are not there, that does not participate in making a candidate key, is the non-prime attributes. And then you apply the formulas and check, right, whether it will be in BCNF, whether it will be in third NF, 2NF, or in 1NF. So if it is not in 2NF, that means you understand the table anyways by default this table is in 1NF only. So you have to check whether it is highest normal form. So you have to check first whether it is in BCNF or not, whether it is in 3NF or not, then 2NF. You have to check 3 conditions. Okay. So can you do it?
Yes, ma'am.
Yes, ma'am.
Okay. Please try it and show me. Okay.
Okay,
In the
ma'am.
next class.
Okay,
By
ma'am.
tomorrow, everyone needs to show me. Okay.
Okay, ma'am.
Okay. Thank you, everyone. So this was a small topic I was to discuss today. So tomorrow we'll go for decomposition. Okay. I'll be sharing the slide of BCNF and 4th NF by today. Okay. Thank you, everyone. Just wait. Let me take the attendance. Okay. Thank you, everyone. You all can leave now.
Thank you.